Hello everyone, my name is Jacob Concienne and I'm a senior at American Military University, and today I will be presenting a microcosm experiment that I've conducted. Why this assignment? This project provides a hands-on opportunity to explore ecological principles in a controlled environment. It allows for observation of interactions within a small-scale ecosystem, offering insight into the complexities of larger systems. Beyond fulfilling academic requirements, the goal was to gain a deeper understanding of ecological dynamics and apply theoretical knowledge. My goals and learning objectives: I wanted to see how organisms coexist, compete, and depend on each other. I wanted a better understanding of the role of abiotic factors on a micro ecosystem. And then I wanted to observe the factors that contribute to an equilibrium or disruption within an ecosystem. Why are microcosms useful? They allow us to manipulate variables to study cause and effect relationships. They can be used to predict behaviors in a natural ecosystem, and also help us understand population dynamics, resource use, and ecological resilience. What do you need to know? Well, what is a microcosm? It's a simplified ecosystem that mimics the interactions and processes of larger ecosystems. The basic components are going to be producers, consumers, decomposers, and then abiotic factors. Key concepts is how is the energy being flown through the system, movement of nutrients like nitrogen and carbon, and then the maximum population size the system can sustain. I came up with 3 different hypotheses here. The primary one was if nutrient levels are artificially increased in the microcosm, then I should see a bunch of algae growth. And this assumes that freshwater drain ditches often contain nutrient-limited ecosystems, especially in urban places like Honolulu, where mine was taken from. And then the second one here is if small invertebrates are present, their population will increase initially because there'll be a ton of food, but then it'll either stabilize or decline over time because they'll deplete the resources. Tertiary is if abiotic factors such as light exposure or temperature are altered, the composition of the microcosm will shift, potentially reducing biodiversity or altering species dominance. Just a little side note, in Honolulu this time of year we're roughly anywhere between 75 to 85 degrees Fahrenheit. We have a lot of rainfall this time of year, and that could play into what I collected. How I put it together, you can see on the map here that I'm in between Aiea and Honolulu. We're still part of Honolulu, but specifically I'm on the Ala Moana Military Reserve, and I grabbed my stuff right out of that little square there. How I put it together, I took roughly 120 milliliters of substrate, roughly 600 milliliters of water. Then it left me with approximately 130 milliliters of air. I grabbed around 2 grams of pond water starwort, which later I found out to be moneywort. And then there's also about a half a gram of hair algae in there. All my items were placed into a quart-sized jar, starting with the substrate, followed by the water, and then the plants. See, I corrected myself here with the moneywort. My average growth of the moneywort, you can see in the chart here, and I was really surprised and pleasantly surprised, I should say, that I ended up with about 76 millimeters of growth. This is an approximation because I'm trying to measure with a ruler from the outside of a jar that kind of, it curves up at the top there. Week 1, when I collected everything, it was overcast. I had a lot of green leaves. We had hair algae and the moneywort in there. I didn't mean to, but I actually collected a few snails, and water was cloudy from placement and transportation. Next week we had overcast as well. We had hair algae, and everything was still green. Had a few more snails that were visible. The water was cloudy because I think my kids had picked up the microcosm and tried to find some snails. But I do know that it had settled down because I had checked it earlier in the week prior to making the observations. Week 3, we were partly sunny, green and vibrant. I had a lot more string algae in there. This week I started to notice that there was snails and copepods, but it seemed like there was less snails. Week 4, we had about 50% cloud cover throughout the week. We had a silt substrate, hair algae. It was very stringy this week. All I could see this week were copepods. I did not see any snails, and that left the big question of where did the snails go. So week 5, it was sunny. It had been in indirect sunlight. Very healthy plants in there. I did not see any copepods or snails, and I started to wonder if the recent heat wave that we had in the Hawaiian Islands was too drastic of a change in a glass jar. Week 6, I started to see more hair algae, and the moneywort. I know it says water starwort there. That was misidentified until very late in the experiment. Was growing very well. I started to see nematodes. They were very, very small. I got excited. Life was in there. Just not the snails and copepods. Week 7, we had another sunny week. The plants were still growing. I saw a lot of nematodes. Now this is the final week of observation prior to me bringing everything in and getting going. Well, excuse me. I am still wondering if the heat outside had something to play with my heterotropes in there, because once I brought my microcosm inside and started giving it indirect artificial light, I can see a lot of copepods, and my snails are back. So they must have just really been good at hide and seek. So what happened in the experiment? Well, I had 76.2 millimeters of growth in my moneywort. I had notable changes in species presence, whether that was them hiding or the life cycle, I'm not sure. But snails appeared early on, then declined. Next up were copepods, and then they disappeared, and then nematodes, and that was the latest population shift from my observations, other than the one that I saw today. Additionally, the hair algae experienced substantial growth, and that possibly benefited from nutrient availability or maybe reduced grazing pressure if the population was stabilizing with the snails and copepods. Did my observations support the hypothesis? The first one, increased nutrient levels. It was supported because both the moneywort and the hair algae thrived, demonstrating nutrient-driven productivity. Second one, populations will stabilize over time. I put this was partially supported, and at the time is because of the fluctuation in temperature, and with the snails and copepods coming in and out. I still think that this is partially supported, and I'm excited to see what more time will do to watch this stabilization. My tertiary changes in abiotic factors will alter species dominance and diversity. Again, partially supported. While the abiotic factors were stable, and again, I didn't test or observe my temperatures the entire way through. The shifts in species composition suggest that underlying ecologic pressures such as composition, nutrient cycling, or niche replacement was happening. Again, I think more time is needed to observe that. Key takeaways. The microcosm highlighted the dynamic nature of ecosystems with rapid shifts in species presence and dominance. The plants in there thrived, suggesting the importance of autotrophs in maintaining ecosystem structure. The decline of snails and copepods, followed by the emergence of nematodes, points to the influence of resource availability. Again, this was my observations as of Friday, and then bringing it in here, maybe that stabilized it out. I'm going to keep monitoring this even after the class. And then this experiment demonstrates the value of microcosms for understanding ecological processes like succession, competition, and nutrient cycling. Course concepts. First one was ecological succession. Definition: the process by which ecosystems change and develop over time, involving shifts in species composition and interactions. The relevance is the appearance of the snails and their subsequent decline. The emergences of copepods and later nematodes demonstrate a clear pattern of ecological succession within the microcosm. Each species occupied a niche until resource constraints or other factors led to changes, mirroring natural processes in larger ecosystems. Second one is our nutrient cycling, the movement of nutrients like nitrogen and phosphorus through biotic and abiotic components of an ecosystem. The relevance is nutrient availability drove the growth of primary producers such as moneywort and hair algae, while the decomposition of dead organisms likely contributed to nutrient cycling within the microcosm. This aligns with the fundamental concept of nutrient cycling explored in the course. And then trophic dynamics. The relationship and energy flow between different levels on an ecosystem, from producers to consumers and decomposers. The microcosm displayed trophic interactions with snails and copepods, initially serving as primary consumers of algae. Their decline followed by the rise of nematodes, and the continued dominance of autotrophs reflects the interconnectedness of trophic levels and the energy limitations within the ecosystems. Thank you for sitting through my presentation.